All right, so take a quick moment to check out your answers on 1 through 17 on the calculations. You really need to be able to work around that four-corner diagram. If you can't do that, you're not going to have a good time in the test. Remember that our test for this information is on the day of the final. We'll have a 1-hour review before it, and then we will take that. This packet that you guys have does have a review guide in it. So that would be a start. On the day of the test, we'll see. Maybe I'll get a what do they call it? Complimentary review guide. We'll see about that. I'm get attendance now. Yeah. This is like my biggest class, I think.
Like biggest in-person class?
Biggest people, like just the sheer number of students. It says like 18 people on the Zoom, which is huge. 10. AP Chem has like, those kids know they have to come in and take the AP test. So they come in person to class too, most of them.
So where your most fun?
Yeah, I would actually, you are my most fun class. Period 9 is my favorite class. And period 5, 6 is my coolest class. And period 9 hates the fact that 5, 6 is my coolest class. And I got to tell them today that they're not my most fun class, but you guys are.
Yeah.
Yeah. Right? You what? What don't you approve of?
Well, it wasn't one of the ones. I think that were like 75% of school plus 75%.
Yeah, it's really close, right? Yeah.
Which means it's over with everything. Yes.
Yeah, you can look at it that way. But why does it got to be better?
And we just are.
Because we just are. There you go.
All those other kids are losers. They wouldn't be great enough to grab.
This is on video. That's
Hey,
that's
all the
Henry.
other ones are losers.
Henry HENRY. All right, let's take a look here. Make sure I got this. Amara. Matalucci is here. Bella is J. Emily is here. Hannah is here. Hannah, that test is going to be online. I know that you're not going to be feeling the best, but you're more than welcome to take it like that whole day. It shouldn't take you more than 60 minutes, even though it's 90 minutes long. It's totally up to you, though. It is optional. I just want you to make sure that you know you're more than willing to take it, and it's no hurt too if you take it and you're like, this sucks, whatever, close my computer, I don't feel good, then do it. I mean, yeah, that's perfectly fine. And please keep in mind, you're not going to hurt my feelings if you don't take this test. Some people are like, well, I don't want to not take the test and make so and so feel bad, and that's not the way I think. If you don't want to take it, don't take it. Boom, done.
Well, you're gonna make Mr. Jackson cry.
Yeah, you're not going to make me cry.
Hard on this test.
So it does take me about 3 hours to make the test, but there are some people that need to pass it in order to pass the class. Those guys are the real crazy people, right?
Wait, is it a no hurt final?
You got it, but it's not a final either. It's a unit test. Just want to make sure you understand that. It's only worth 10% of your final grade too, instead of the 20. Since they changed it to a no hurt, we dropped the percentage down to a 10%. But if you're failing and you pass the final, you pass the class.
Is that just science department who did that?
It is just Mr. Jackson and the fellow chemistry teachers.
Okay.
That is something that is decided by the PLC. And you don't even need to know what that is. Right. So do we have everybody?
Parental leader council.
Learning community, personal learning community. Maybe.
That's not school.
Yeah, right. Professional learning community.
There's an exclamation mark.
Professional learners conquistadors. Conquistador is like a cool thing, I think.
Pretty sure those are the Spaniards that like took over.
Conquerors, yeah. It's
Yeah, they had some
probably it's still a cool name or word.
I always, if I go to this restaurant I go to, they have this conquistador, and it's got like 2 taquitas, a burrito, 2 enchiladas. They bring out a separate plate because the other plate's not big enough. Put like an awesome taco on. Yeah,
Take a look at those answers. Ever been to Chris's over there? Chris's ice cream?
Yeah.
Yeah, so you ever get their Diablo sauce, the red one?
I went like a once with William.
Whoop, whoop. That Diablo sauce, I still have some. So last night I bought tortillas and we make some burritos for lunch and use that. Oh no, I forgot cheese. That wasn't very smart of me.
So what page is this on?
This is between the acid base calculations and the Lewis dot. What is it? No. Or they exist here in Indy? Where is that at? 86th Street? What was the place that's now a comedy club on 86th Street? What did that used to be? Don Pablo's? Yeah, and it became what would I call it? A comedy club? All over? I'm sure that there are private ones somewhere. Any questions about those? These problems here, if you are just writing down answers, re-download it and make sure that you get make sure that you go through these problems because this is going to be probably about 20% of it. I'll chuck some numbers in there and all of that stuff. Like it's going to be a big part of it. But let's shift gears then, and we will go to the other stuff. But let's just take a second to admire the conquistador. For $11.99, you get beef taquitos, like 2 or 3 of them, chicken flautas, mama skinny enchilada, mini beef burrito, and there's so much that the crispy beef taco and the soft chicken fajita go on the side. Have you guys ever had Don Pablo's sweet corn cake? Oh my gosh, sweet corn cake is amazing. But yeah, pretty good stuff. Too bad they closed down. Must not have been that good, right? What'd I say? I said something wrong?
Yeah, you said like the first 3 things.
That's actually the first time I've ever been wrong in my life. This is kind of a big moment for me. Which part was wrong?
The first 3 items.
Huh. I'm going to disagree. I've heard it pronounced both ways.
Copy and paste it into Google Translate.
It's Henry again. All right.
Yeah, I'm just trying to correct something.
Huh. Did you guys hear that? Henry's just trying to correct somebody. That's an amazing way to say that, right? Like, I was trying to correct you because you're wrong.
I don't want to look stupid.
That's amazing right there. If I thought he was a jerk before, he totally made me for sure of it. Like there's no more thinking about it, right? All right, so yesterday you guys were supposed to that's why this is a fun class. Yesterday you guys were supposed to take and figure out what the Bronsted-Lowry acid and base was. I said that the acid donates a hydrogen and the base receives a hydrogen. So if we're looking at this, it says, are these Bronsted-Lowry acid-base pairs? Well, you look. Now, the only thing is that a hydrogen actually has a charge. So if we lose one hydrogen, we lose a positive, which makes us negative. So you're looking for a change in one hydrogen, and you're looking for a change in a charge. If that does not exist, here it exists. We lose a hydrogen, we gain a negative. Here, we lose two hydrogens. So that's not a Bronsted-Lowry acid-base pair. Here, we lose a hydrogen and an oxygen, not a Bronsted-Lowry acid-base pair. This stuff seems complex, but we're talking about the change of one hydrogen, right? So this is not that difficult. This is not, I mean, it may take you a few times to go through it, but it's not as hard as saying the words that I messed up on. I'm willing to admit the first mistake I've ever made.
Like 300 times this semester.
Did I? I admit to those two. So if we take a look here, they ask you to look at the reactants and determine which one is an acid and a base, and then look at the products and determine which one is the conjugate acid base. Now, this seems crazy at first, but just realize that the acid loses a hydrogen and the conjugate base is what's left after you lost that one hydrogen. We have the negative charge because a hydrogen is positively charged. So we have that negative charge because we lost a positive. Let's take a look down through there and see 9 through 22. How many mistakes did you make on this one sheet alone? I didn't make any because I didn't do it, Mr. Jackson.
Got that right.
Make sure you download this and try a few of these. These, like, are you taking the final?
Yeah. I'm taking all my files.
Why don't you guys just stay at home? Because it's taken online. You're not going to sit here and take it, are you? No. Good.
I want to feel like I don't.
All right.
If I'm at home with all those boom flickers, cheap on everything.
Not only is he throwing shade at me today, but apparently it looks like that you guys are on his radar as well.
They're always on my radar.
Yeah, the final will be all online. The thing is like during that time, I'm going to be like cleaning up the laboratory for the final time and doing a bunch of stuff. So, I mean, if you guys want to take it at home, figure out a way to stay home. I'm actually surprised that the administration didn't save a bunch of gas with the buses and stuff like that and have everybody take their finals at home. But I guess there's a lot of APs next week. Next week, are you coming finals week? Yeah, just doing it.
This any time with you.
Oh, my God. And then Seth, just when I thought Henry was the worst kid in the class, Seth, no, I'm just kidding. Seth blows him out of the water.
You guys on Zoom for the next one yesterday. You were kind of lighting stuff on fire. I mean, we were trying to light stuff on water.
Yeah. All right, take a look at these. These are a little bit different. So it says write a balanced equation showing, and we did not do these yesterday. So I'm going to go ahead and work through these with you now. So what we want to do is we want to write a balanced equation that shows the following. It says acting as a base. So if you've been halfway paying attention, this is probably the most important part of today's lesson so far. So we have NH3 being a base. What does a base do? A base accepts a hydrogen. So we're going to take one hydrogen away from H2O, and we're going to put it on NH3. Well, what's NH3's current charge? Nope. 0. There's no charge up there, so it's 0. If we put another H on it, what's its charge now? 1. And what's left of H2O if we take off an H? HO, which we write as hydroxide. Since it lost an H, what's its charge? It lost a positive, so it is -1. F negative acting as a base. So F negative is going to get a H from water. So it's going to become HF. What's its charge if it gained an H? 0. So we're good. And what's left of water? And its charge is negative. The next one says write an equation with the following being an acid. So HF is an HI is an acid this time. So it is going to lose an H, and it's going to give it to H2O. So if HI loses an H, it becomes I with what charge? Negative. And if H2O gains an H, it becomes H3O. And what's the charge? 1. NH4 plus, we're going to add water to it, and it's going to lose an H. So we're going to get NH3 with no charge and H3O with a charge of +1. Good. There we go. Questions about 31 through 34? All right, then. Now we're going to do the hard stuff. What's this look like on your guys' packet? Just want to make sure that you guys have this chunk at the top on your packet. That's the top of your packet? All right, cool. I just want to make sure. It looks like I have some X packets here.
So that's on the bottom.
Oh, it's on the bottom of the previous page. Okay. So you should finish those up for Monday. And what we want to look at is the H2HOH thing. Acid-base neutralization. Acid-base neutralization. So if we take an acid and we mix it with the base, they neutralize each other to make salt and water. We actually learned this if you had me last semester, we learned this when we did the reactions laboratory. That was before we started having any students in class. Basically, it's filmed me doing many reactions and seeing color changes and stuff like that. But we talked about that neutralization reaction. So this is kind of cool because there's 2 ways you can do this. I'm going to show both ways to you. So it says scientists use a procedure known as titration. That's actually the last laboratory that we do in this class. That will be next Thursday and Wednesday. This titration is to determine the concentration of an unknown acid or base. You're going to determine the concentration of acetic acid. By using a known concentration to neutralize the unknown, an indicator is used to denote the neutralization through a color change. Indicators basically turn colors. The indicator we're using is known as phenolphthalein, and it changes from clear to pink whenever a solution becomes basic. So that's where we'll know is right whenever that stops being clear and turns basic, we'll know that that's the endpoint when it turns pink. We call that change the endpoint. That's where we stop. So for each of the problems below, you should write a balanced equation. So we're going to start off with a balanced equation. So this is a good review for all of us. We have KOH. We're going to add to KOH phosphoric acid, which is H3PO4. Anybody remember double displacement reactions enough to tell me what's going to form? What happens in a double displacement reaction? The first 2 things do what? Switch. So hydrogen is going to switch places with potassium and make HOH. What is HOH the same as? Water. So we're always going to get water. And then we're going to get a salt. Potassium is going to switch places with H. So we're going to get K because of cation and PO4 for the anion. The problem with K and PO4 is the electrons do not cancel. What is the charge of K? Use your periodic table if you got them. Use your periodic table if you got them. Plus, you're gonna let the Zoomers beat you. +1. Come on, Zoomers, it's a competition. What is the charge of PO4? That is phosphate. -3. -3. If you're at home and you think that Seth is a genius, you just need to get a periodic table. You are pretty smart. Henry's actually complimenting somebody. Way different than normal. So Seth was able to look at potassium and look up here and see, oh, it's a +1. So he's good at word find puzzles. Are you good at word find puzzles? Yeah, yeah, he's like, yeah, I am. One of the best. And here, if we look at PO4, we've got a 3 negative here. So that's how we got those charges. Now, a real genius would tell me how we should write KPO4. Oh, come on, you did the hard part. How many Ks do we need to cancel out the PO4? 3 Ks. Now he's on there. He's playing with power. Since we have 3 Ks, that's bringing us back, right? Since we have 3 Ks on this side, what's wrong with this side? It only has 1 K, so what do we need to do? We need to multiply it by 3. So we'll put a 3 in the front of it. So that's 3 KOHs. We have 3 H's and we have 3 H's. That's a total of 6 H's over here. We only have 2 H's over here. So what are we going to put in front of that? 3. That's how we have a balanced equation. Right? That actually should probably seem easy since of everything we've done since then. I mean, yeah. It was last semester. Yeah, it was.
Yeah, that was like full.
Henry just realized what it means for time to go by. That was a while back.
Yeah, and that means my brain doesn't remember it.
Him's brain's not working so well.
Yeah, because I have like 5 questions.
Oh my gosh. He did have this awesome hit from lacrosse. You can catch it out on www.youtube.kzy.
It's at roncalli.com. It's
roncalli.com.
Tuesday night, against versus Eastside Lacrosse.
Versus Eastside Lacrosse last Tuesday night. You can see him. The announcer talks about Henry being.
It's in the second period. I get smacked in the face.
But it looks like he got punched in the gut,
Yeah.
according to the announcer. So we got the balanced equation. We know that we have 1.56 moles of phosphoric acid. And watch this, because if you look away right now, you're going to look back and you're like, oh, he did math stuff. So pay attention. I'm doing the same math stuff we've always done. Moles of H3PO4 is going on bottom. There's no number in front of here. So it will be 1 mole of H3PO4. I want to get moles of KOH. So on top, it will be how many? 3 moles of KOH. Guess what? That's what I want. I'm done. That's just a stoichiometry thing. 1.56 times 3.
The answer is 4.68.
4.68 moles of KOH. What happened to moles of H3PO4? They canceled out. Bada bing, bada boom. What do you think?
And the Zoomers have to wait there and say, you know what?
Did you guys look away?
That confirms it.
Confirmed. So I'm going to let you do 2. That is the same type of problem as that. I'm going to move down to 3. And I will do 3 the same way I did there. And I will do 4 using a different technique. So let's take a look at 3. how many milliliters? So I'm looking for milliliters. How many units does milliliters have? 1. So that means I need to start over here with 1. How many milliliters of 0.45 moles per liter? Molarity is 2 units. Moles per liter of HCl must be added to 25 milliliters of 1.00 KOH to neutralize it. A lot of stuff going on here, but the only number that's in here that also has 1 unit is 25 milliliters. So I'm going to start over here with 25 milliliters. As I said before, you need to start each of this with a balanced equation. So we have HCl plus KOH. What's one of the compounds going to be made by this? Always in these neutralization reactions, water. Good. And what's the other one going to be? Salt. In this case, it's going to be potassium chloride. What's the charge of potassium? We just did that. +1. And what's the charge of chloride? 1. So the ratio there is 1 to 1. So I've got milliliters of KOH here. So that means milliliters of KOH needs to go on the bottom. Every 1,000 milliliters of KOH is 1 liter of KOH. Remember, molarity is moles per liter. So every 1 liter of KOH is 1 mole of KOH. Now, every 1 mole of KOH is 1 mole of HCl. And every 1 mole of every 0.45 moles of HCl is 1 liter of HCl, because that's what molarity means, moles per liter. So I can put moles on top or moles on bottom. It's reversible. And every 1 liter is how many milliliters? 1,000 milliliters. 25 divided by 1,000 times 1 divided by 0.45 times 1,000.
It's about 55.5555.
55.6 milliliters of HCl. Seems like a lot of work. I didn't think once. All I did was take whatever's up here and put it on the bottom of the next one until I got my answer. Lucky for you, if you don't like a lot of work like that, there is an easier way, but you have to have this formula memorized and you have to think. The formula is ma va over ka equals mub over kub. The molarity of the acid times the volume of the acid. Actually, it's not ka like that. I'm sorry, it's ka with a C. I got confused because I had ka last period. You guys know ka? So it's actually a C here. So it's molarity of the acid, volume of the acid, coefficient of the acid equals molarity of the base, volume of the base, coefficient of the base. Remember, the coefficient is the number in front of it in a balanced equation. So let's balance this bad boy. What is the molarity of phosphoric acid? If 15 milliliters of solution is completely neutralized by that amount of the base, sodium hydroxide. What's going to form? One of them is for sure what? Water. And the other one, sodium, is going to go with PO4, but it's not going to be NaPO4. What's it going to be? In a what? Nope, NaPO4, but we did a number for the Na. How many Nas do we need to cancel out the PO4? Nope. Nope. What's the charge of Na? 1. What's the charge of PO4? So how many do we need? 3. If we put a 3 Na here, We need 3 NAs over here. How do we do that? We need to put what in front? Multiply it by 3. We have 6 H's. So what do we need to put in front of the H2O? 3. So now we got our coefficients, which are on the bottom. And from the actual wording of the problem, we've got our ma and our va probably, or some arrangement of these. Oh, we want to solve for molarity of the acid. So we want to solve for ma. So I'm going to rearrange this equation. I'm going to multiply both sides by ka. And I'm going to divide both sides by va. So we get ma equals mub ka over kub va. Now it's just a point of putting these into the equation, which you've been substituting in math probably for years. So the molarity of the base is 0.15. The volume of the base is 38.5. The coefficient of the acid is 1. The coefficient of the base is 3. And the volume of the acid is 15. Let's plug that into the calculator. Clear, 0.15 times 38.5 times 1 divided by 3 divided by 15. Like that, we get 0.128 molarity of the acid. Yay, yay, rah. You want to see another one that way? And then I'll let you guys finish up page 11 and 12 for homework. And Henry's back on top. What is it? We're doing acid-base neutralization. Can't you guys just neutralize an acid or a base?
So remember, secondary.
Oh my gosh. Let's take a look at this one. This one will be a little bit fun. So let's start by writing a balanced equation. We have sulfuric acid plus sodium hydroxide. What's one thing that's going to form for sure?
Water and salt.
Yeah, water and salt. We need to figure out what the salt is. What's the salt going to be? Nope, sodium hydroxide is the base. Sodium's going to pair up with 2.
On the outside. Hydrogen moves from the sulfuric acid to what's left after we move the hydrogen from the H2SO4.
What's left? H2SO4 minus the hydrogens is what? Just SO4, right? So it's going to be sodium's going away with SO4, but we got to check charges. What's the charge of sodium? 1. What's the charge of SO4?
I mean,
-2. So how many sodiums are we going to need? 2. That means we have 2 sodiums on this side. What do we need to put on this side? Multiply it by 2. So the coefficient of the base is 2. And we have 2 plus 2 hydrogens. So what do we need in front of the H2O? 2. Good. So we got our balanced equation. What do you guys want to do? Do you want to do Mava over Ka, or do you want to use all those stoichiometry? Not an option.
on the mama.
Mava over Ka. All right. Why did you? Because it's fun to say, or do you like formulas better than stoichiometry? Just like hearing me say it. So what are we looking for? We're looking for the concentration of the acid, so we're looking for Ma. I gotta say with the Boston accent. Who are you talking about, Bonnie and those cars? Mava over Ka. Huh. So we're looking for Ma. We need to rearrange this equation. We're going to divide both sides by Va and multiply both sides by Ka. Molarity of the base. Molarity of the base is 0.010 molar sodium hydroxide. Verb, that's the volume of the base. It's 10 milliliters. Now, what you might be asking yourself is, Mr. Jackson, but this is in moles per liter and this is milliliters. It's okay as long as our acid volume is in milliliters because that will cancel out. The Ka is 1. The kub is 2. That's the coefficient of the base. And the Va, that's the volume of the acid, and it is in milliliters, so we're good there. Now again, like I told you, this milliliters will cancel out. So let's take it and put it in a calculator. We'll clear it. 0.01 times 10 divided by 2 divided by 60. Oh, yuck. Very small number here, so it's best to put this in scientific notation. 2 significant digits there. So our final answer will have 2 significant digits. So we're looking at 8.3 times 10 to the negative 4th. What's the unit left? Molarity. Bada bing, bada boom. Your assignment is to do page 11 and 12, finishing those titration problems for Monday. And the lab is due Monday. If you get it done by Monday, I'm okay with that. I'm not going to grade it over the weekend. I have a big busy weekend. Any questions? If you got questions, stay after. Otherwise, get out of here and have a good weekend.
Hey, I came in at like 9:13. Did you already do attendance by then?
I did. Who is this?
Micah.
Micah, let me check. I got you.
Okay, cool. Thank you.
You're welcome. Is the computer working for you okay again?
Yeah.
Yeah. Good.
Thank you.
Have a great weekend, guys. Take care of yourselves. Take care of others. And hey, kiss your mother. It's Mother's Day.
Thank you. Have a good weekend.
Thank you too, tomorrow. Have a great weekend.
I'm gonna require all the cameras on one day next week. That way we can all see what they look like.
Do we? Do we need that? What if they